Good afternoon, everybody. This is Mrs. Peachy from your physical science class. I am recording a tutorial on how to do the momentum portfolio. First thing I want to say is that we are shortening this portfolio. It is quite long, and what is listed in the course tree here is just kind of too much stuff. So I'm going to move this over just a little bit here, but if you can see here, we have a lab day 1 and a lab day 2. Don't do lab with day 2. It's not necessary. That's just overkill. Okay. What we want to do is do lab day 1, and what I'm emphasizing is the conservation of total momentum. Now it's real tricky for me to kind of go through this in a tutorial like this. The idea is that if you've got two objects and those two objects are moving, that an object in motion is going to have mass and it's going to have velocity. So mass times velocity is momentum. And if you've got a second object, it also has a mass and velocity. So it also has momentum. If these two objects come together and collide, they both still have the same mass, but they probably don't have the same velocities after the collisions, right? But law of conservation of momentum says that while that might be true, the conservation, or their momentum, is conserved. The total momentum of the two of them together is conserved. And it's basically just like this. The mass of the first object times its velocity, and you add the mass of the second object times its velocity, right? After they collide, the total will still be the same. So this part here is just showing their final velocities. Up here, this was their initial velocities. But if this is 100, then this will be 100. They'll be the same. Again, masses don't change, so it's the velocities that are changing, but if you add them all up, they're still the same. It just gets distributed differently. If you want any more information on that, I will be doing an entire live lesson on momentum. So, alright, so within your course tree, it's going to ask you to click here, which will open up a PDF. And please remember, save your PDF to your computer, open that, type into that one, and then resave it before you attach it to the Dropbox, okay? Hopefully by now you all got that kind of figured out, but you'd be surprised. Okay, so I'm going to open this up real quick. And let's see here. Okay, I kind of get interrupted there for a moment. I apologize for that. So I'm going to click on, like I said, the PDF, and let's bring that over here. Again, you'll have to save it to your computer before you can actually make entries into it. But basically, it's going to have you choose the masses and velocities of two balls and observe what happens in a collision. If I go to the link that it gives me at the bottom of the screen, it's going to bring me to this type of screen here. I'm actually going to click on the home button just so that I can show you exactly where it starts. So it'll ask you, here we go, go to lab. You're going to do the sim, proceed, and we're going to start with the perfectly elastic collisions. So just FYI, an elastic collision is kind of like bouncing a tennis ball off of a wall. it conserves the velocity. It really doesn't lose a lot of velocity, right? It's going about as fast on the back bounce as it was on the forward bounce. So that's what we're going to start with. Okay, and you can choose whatever mass and whatever mass you want for object 1 and object 2. So I'm going to start with 10, maybe. There we go. 10 kilograms for object 1, and I've had oh, I finally got 5. Sorry, this is like my 4th time trying this, and this is like take 4 on the video, but I finally actually got 5. Okay, that's exciting. So 10 and 5, easy numbers to work with. And then we're going to go ahead and start this. Before I do that, I want to make sure that I write my information down so I don't forget. So I'm putting down my initial mass of ball 1 as 10 kilograms, and ball 2 is 5 kilograms. Okay? Okay, then we're going to go back here, and I'll place ball A and B, or 1 and 2, into their proper slots. And then I can give them both starting velocities. So ball A was 10, let me give it a velocity of, I don't know, 5. And ball B was 5, so let me give it a velocity of negative, oh, I had it, see it? There, negative 10, exciting. Alright, so let's write these down. Ball A is 5, ball B is negative 10. Okay, whoops. Okay. So then the next step is to push play, and you are going to wait for them to collide and then pause the experiment to see their velocities. Okay? So I'm going to move this over a little bit so you can kind of see the graph. And I'll move me too. There. Alrighty, so let's go ahead and push play. There we go. So we can pause it, and then you can see now the velocity of ball 1 is negative 5, the velocity of ball 2 is 10. So let's go back to, so this is negative 5, this is 10. Okay. So now what you're going to be doing is you're basically going to be looking at conservation of momentum. You want to look at mass times velocity before the collision for each ball, and mass times velocity after the collision for each ball. Lots of questions to answer here. Okay, and basically some questions and some explanations. In short, ball A is 10 kilograms. And its speed was 5 meters per second. And you got a 5 kilogram ball at negative 10 meters per second. That was before the collision. After the collision, the weights didn't change, or the masses didn't change, but the velocities did. Oopsies. So you can kind of see that when you look at that there. 10 times 5 is 50. Negative 10 times 5 is negative 50, so 50 plus negative 50 is 0. And the same thing on this side, 50 plus negative 50 is 0. So it's just showing us that 0 does really equal 0, and so that's the law of conservation of momentum. The next thing it's going to tell you to do is to set the mass of ball A to twice that of the mass of ball B and make sure their velocities are equal. So you need to come up with, let's say, ball A is 20 kilograms and ball B is 10 kilograms, and then you put their velocities both at 10 or something like that. just pick whatever you want to for numbers, but make sure they follow the directions. You're going to hypothesize in advance what do you think is going to happen. And then you're going to actually do this. Set the velocities and the masses. You're going to carry it out, and you're going to reflect upon your hypothesis. Now remember, the hypothesis is saying, would the total momentums, or excuse me, how would the total momentums before and after the collision compare? So I want you to tell me how the total momentum, which is what I have here, remember, that's my total before and my total after. I want you to see for this one, how would total momentum compare? Okay? Same thing for experiment number 3. Only this time you're going to be doing ball A has twice the velocity of ball B, but their masses are equal. And then for experiment 4, you're going to do an inelastic collision. Okay? And for that, remember, you're going to have to go back to the beginning and choose perfectly inelastic collision instead. So once you have all those questions done, the math is just limited to MV plus MV. It's not that difficult. But if you have questions, let me know. That PDF is what you will return in to me through the Dropbox, okay? If you have any additional questions or concerns, feel free to give me a call. My phone number is 2204, or you can always drop me a webmail. Have a good day, everyone.